In programming, we often need to do the same task many times. Imagine you need to print hello 100 times. You could type the print command 100 times. That would be very slow and boring. It would also make your program very long. There is a much better way to do this. We can use loops. Loops are a fundamental concept in Python programming. They allow you to repeat a block of code multiple times. This makes your code shorter and easier to manage. Loops are incredibly useful for automating repetitive tasks. Think about sending a personalized email to a list of subscribers, or perhaps you need to process every file in a folder. Loops can handle these jobs efficiently. Without loops, writing such programs would be very difficult. You would have to write out almost the same code again and again. This repetition can also lead to more mistakes. If you need to change something, you have to change it in many places. Using loops saves a lot of time for the programmer. It also makes the program more powerful. Instead of telling the computer every single step for every single item, you tell it how to process one item. Then you tell it to repeat that process for all the items. This is a core idea in programming. Write once, use many times. Loops help you achieve this very effectively. They are one of the first powerful tools you learn in Python. Consider a simple, real-world task like washing a stack of dishes. You perform the same set of actions for each dish. You take a dish, scrub it, rinse it, and then place it on the drying rack. You repeat this process until all dishes are clean. A loop in Python works in a similar way. It takes a set of instructions, the code inside the loop, and executes them repeatedly. This repetition continues for a specified number of times or until a certain condition is met, just like washing dishes until the sink is empty. One common type of loop in Python is the for loop. For loops are used when you want to iterate over a sequence. A sequence can be a list of items, a string of characters, or a range of numbers. The for loop will go through each item in the sequence one by one. For each item, it will execute the block of code indented underneath the for loop statement. This makes it very easy to work with collections of data. You don't need to know how many items are in the sequence beforehand. The basic syntax of a for loop in Python is quite straightforward. It starts with the keyword. This is followed by a variable name that you choose. This variable will hold the current item from the sequence in each iteration. After the variable name, you use the keyword. Then, you specify the sequence you want to iterate over. The line must end with a colon. For example, you might write, "This tells Python to take each item from and one at a time assign it to the variable." The variable you define in the for loop, like in the example, is very important. In each pass or iteration of the loop, this variable gets updated. In the first iteration might be apple. In the second it might be banana, and so on. You can then use this variable inside the loop's code block. For instance, you could print the or perform some calculation with it. This variable allows you to access and work with each individual element of the sequence. The sequence part of a for loop can be various things. It can be a Python list like, it can be a string like. If it's a string, the loop will iterate over each character. Sh, then E, then L, then L, then O. You can also use the function to create a sequence of numbers. For example, creates a sequence from 0 up to, but not including 5, so 0, 1, 2, 3, 4. This is very useful when you want to repeat an action a specific number of times. Let's look at a simple for loop example with a list of names. Suppose you have a list. You can print a greeting for each name using a for loop. The code would look like this. Then, on the next line, indented, you would write. This loop will run 3 times. First will be Alice, and it will print, "Hello Alice." Then will be Bob, printing "Hello Bob." Finally, it will print "Hello Charlie." For loops are also great for working with strings. Remember, a string is just a sequence of characters. If you have a string, you can iterate through its characters. You could write, inside the loop you might have, this would print each character on a new line. P, then Y, then T, then H, then O, then N. This can be useful for analyzing text, counting specific characters, or performing other character-by-character operations. It's a simple yet powerful way to process textual data. The function is frequently used with for loops. It generates a sequence of numbers which is perfect for when you need to do something a fixed number of times. For instance, if you want to print "still learning" 5 times, you can use. Inside the loop, you would write. The variable will take values 0, 1, 2, 3, and 4, but we are not using in the print statement here. The loop simply runs 5 times. This is very common for controlling repetition. You can also use for loops to perform calculations on items in a list. Imagine you have a list of numbers like, you can calculate their sum. First you would create a variable before the loop. Then, you'd write. Inside the loop you would update the total. After the loop finishes, the variable will hold the sum of all numbers in the list, which is 150 in this case. This shows how loops can process data within a collection. Another important type of loop in Python is the while loop. Unlike for loops that iterate over a sequence, while loops repeat as long as a certain condition is true. The loop will continue to execute its block of code again and again. It only stops when the condition becomes false. This makes while loops suitable for situations where you don't know in advance how many times you need to repeat. The repetition depends entirely on the state of the condition. The syntax for a while loop starts with the keyword. This is followed by a condition that evaluates to either true or false. The line must end with a colon, just like a for loop or an if statement. The code that should be repeated is written on the following lines, indented underneath. For example, the code inside this loop will keep running as long as the variable is less than 5. It is very important to understand how the condition works. The condition in a while loop is checked before each iteration. If the condition is true, the code block inside the loop is executed. After the block is executed, Python goes back to the line and checks the condition again. If it's still true, the block runs again. This process repeats. If the condition is false when it is first checked, the code block inside the loop will not execute at all. The program will simply skip over the while loop. A critical aspect of while loops is ensuring that the condition eventually becomes false. If the condition always remains true, the loop will run forever. This is called an infinite loop. An infinite loop can cause your program to freeze or become unresponsive. Usually somewhere inside the while loop's code block, you need to include code that changes a variable involved in the condition. For example, if your condition is, you might increment by 1 in each iteration. This ensures we'll eventually reach 5, making the condition false and stopping the loop. Section 5. Real-world scenarios for while loops, when to use them. While loops are particularly useful for input validation. Imagine you need a user to enter a positive number. You can use a while loop to keep asking for input until the user provides valid data. You might start with a variable. Then, your loop condition could be. Inside the loop, you ask the user for input and convert it to a number. If they enter a negative number or 0, the condition remains true, and the loop asks again. Once they enter a positive number, the condition becomes false, and the loop terminates. Simple game loops often use while loops. A game might continue as long as the player wants to keep playing or until a certain game over condition is met. You could have a variable like, the main game loop would be. Inside this loop you would handle game logic, get player input, and update the game state. If the player chooses to quit, or if they lose, you would set. This change would make the while loop's condition false, and the game would end. Processing items from a dynamic collection, like a queue or a list that changes during the loop, is another good use case for while loops. For example, you might have a list of tasks to process. You could use. Inside the loop, you would take a task from the list, like process it, and then the list becomes shorter. The loop continues until the list is empty, meaning the length of tasks is no longer greater than 0. So, when should you choose a while loop over a for loop? Generally, use a for loop when you know how many times you need to iterate, or when you are iterating over all items in an existing sequence. Use a while loop when the number of iterations is not known beforehand and depends on a condition being met or a state changing during the loop's execution. If you need to repeat something until a specific event happens, a while loop is often the right choice. It offers flexibility based on runtime conditions. Section 6. The crucial role of indentation in Python, more than just style. Indentation in Python is not just about making your code look pretty, it is a fundamental part of the language's syntax. Indentation refers to the spaces or tabs at the beginning of a line of code. Python uses these leading white spaces to define the structure and grouping of statements. When you start a new block of code, such as the body of a loop, a function, or an if statement, you must indent the lines within that block. This is how Python knows which lines of code belong together. Many other programming languages like Java, C++, or JavaScript use curly braces or keywords like begin and end to define code blocks. Python chose a different path. It uses indentation. This design choice makes Python code often appear cleaner and more readable, as the visual structure directly reflects the logical structure. However, it also means that incorrect indentation will lead to errors or bugs. You cannot just indent code however you like. It has specific rules. The standard convention in Python, as recommended by PEP 8, is to use 4 spaces for each level of indentation. It is highly recommended to configure your code editor to insert 4 spaces when you press the Tab key. Mixing tabs and spaces for indentation in the same file can lead to or unexpected behavior, because a tab character might be interpreted as a different number of spaces by different editors or systems. Consistency is key. If you get the indentation wrong, Python will complain. You might encounter an or a, and specifically means there's a problem with how your code is indented. For example, Python might have expected an indented block after a colon, like in a loop or function definition, but it didn't find one. Or, you might have an unexpected indent. Even if it doesn't cause an error, incorrect indentation can lead to logical errors where your code doesn't behave as you intended because statements are grouped incorrectly. Section 7. Common indentation pitfalls mistakes beginners often make. One of the most common indentation mistakes for beginners is forgetting to indent the body of a loop. After you write for item in my underscore list, or while condition, the very next line that forms part of the loop's action must be indented. If it is not indented, Python will raise n. It is expecting code to execute inside the loop, and the indentation tells Python what that code is. Always remember to indent after a colon that starts a new block. Another frequent error is indenting code unnecessarily. If a line of code is not part of a block like a loop body or an if statement, it should not be indented. For example, if you have a simple script with several print statements, they should all align at the far left with no leading spaces. If you randomly indent a line, Python will raise n. Python is strict. Indentation must have a purpose related to code structure. Inconsistent indentation is a tricky pitfall. This often happens when mixing tabs and spaces, or using a different number of spaces for different lines within the same block. For instance, the first line of a loop body might be indented with 4 spaces, but the second line with only 2, or perhaps with a tab character. Python expects all lines within the same block to have the same level of indentation. Most modern code editors can help you avoid this by converting tabs to spaces or showing invisible characters. Finally, beginners sometimes make mistakes with the indentation of lines a loop or conditional statement has finished. Once a loop's work is done, any subsequent code that is part of that loop must be unindented back to the same level as the loop statement itself. If you keep lines indented, Python will think they are still part of the loop. This can lead to logical errors where code runs more times than you want or not at all if it's indented under a condition that isn't met. Section 8. Debugging indentation tips and tricks for clean code. When you encounter n, the first step is to carefully read the error message. Python usually tries to tell you which line has the problem. Look at that line in your code editor. Then also examine the lines immediately before it. Often the error is because the previous line, like a statement, required an indented block, or because the current line has an unexpected indent or unindent. The error message is your best starting clue. Using a good code editor or integrated development environment (IDE) can save you a lot of trouble with indentation. Many editors can be configured to automatically handle indentation for you. They can also be set to display whitespace characters, spaces and tabs visibly. This makes it much easier to spot if you have accidentally mixed tabs and spaces, or if a line has too few or too many spaces. Look for settings like show whitespace or render whitespace. It is a strong Python convention PEP 8 to use 4 spaces for each level of indentation. Avoid using tab characters directly. Most code editors have a setting to insert spaces instead of tabs or use soft tabs. When you enable this, pressing the tab key on your keyboard will insert 4 or your configured number of spaces instead of an actual tab character. This practice greatly reduces the chances of and inconsistencies across different editing environments. If you are stuck on an indentation error, try to simplify. Comment out parts of your code to isolate where the indentation might be going wrong. Sometimes, retyping the lines around the error, ensuring you use only spaces for indentation, can fix hidden issues. Pay close attention to lines ending with a colon, as these almost always require the next line or lines to be indented. Patience and careful observation are key to resolving these types of errors. Section 9. Conclusion. Embracing loops and perfecting indentation for Python mastery. To wrap things up, loops are truly a cornerstone of Python programming, and indeed of programming in general. Both for loops and while loops provide powerful mechanisms for controlling the flow of your programs, and for automating tasks that would otherwise be tedious or impossible to write out manually. For loops excel at iterating through sequences, while loops are perfect for repetitions based on dynamic conditions. Understanding when and how to use each type will greatly enhance your coding abilities and efficiency. Equally important in the world of Python is the concept of indentation. Unlike many other languages, Python uses indentation not just for readability, but as a strict syntactic rule to define code blocks. Getting indentation right is absolutely essential for your Python programs to run correctly. Incorrect indentation will lead to errors like, or sometimes more subtly, to logical flaws where your code doesn't do what you expect. Mastering indentation is a fundamental step towards writing valid and reliable Python code. The journey to becoming proficient in Python involves practice. Experiment with writing different types of loops. Try them out with lists, strings, and the function. Intentionally make indentation mistakes to see what error messages Python gives you, then practice fixing them. The more you work with these concepts, the more intuitive they will become. Use a good code editor, follow standard conventions like using 4 spaces for indentation, and always pay attention to those colons that signal the start of a new block. By embracing the power of loops and perfecting your understanding of Python's indentation rules, you unlock the ability to write much more complex and useful programs. These concepts are foundational. Once you are comfortable with them, you will find it easier to learn more advanced Python features and to tackle more ambitious programming projects. Keep coding, keep learning, and an exciting world of automation and problem solving will open up to you. Happy programming!